Welcome to all of you. Unit-3 2023 Advanced Mechanics Solution now, Semester 6. Question paper 2023 Advanced Mechanics Unit 3. Question number 4. A. A particle of mass m moves on the inside of a frictionless cone having equation x square plus y square equal to z square tan square alpha. Using cylindrical coordinates, write the Hamiltonian and Hamilton's equations. Let P coordinates with rho phi z be any point on the inside of the given cone. So P, capital P is the point with mass small n with coordinates rho phi z. So this is the distance rho, and the projection of this point P on the xy plane is this point, and this angle is phi, and this distance is rho, and this angle is the z axis is alpha, and this is the so x equal to rho cos phi, x equal to rho cos phi, y equal to rho sin phi, and z is equal to rho cot alpha. Rho cot alpha, it is the height. So this right angle triangle, from this right angle triangle, this angle is alpha. So perpendicular by base is tan alpha. So z equal to rho cot alpha. The kinetic energy of the particle of mass m is given by P equal to half mv square. So half m rho dot square plus rho square phi dot square plus z square, because v vector is this. So v rho, v phi, and vz along the rho and phi along z. And here rho and phi are generalized coordinates, and this alpha is constant. This inside the cone, this alpha is constant fixed. So rho and phi are generalized coordinates. And it will be t equal to half m rho square phi dot square plus rho dot square cosec square alpha, because rho dot square common. So 1 plus cos square alpha is equals to cosec square alpha. The potential energy V of the particle P relative to xy plane. So this is the reference plane is xy plane, horizontal plane. So P is above the reference plane. So this is positive V equal to mgz. So mg rho cot alpha. Lagrangian L equal to T minus T. So L equal to this, equation 3. Generalized momenta P rho and P phi conjugate to respectively rho and phi are given by P rho equal to del rho dot L. So L is this with respect to partial differentiating with respect to rho dot. So this half m into 2 rho dot square cosec square alpha. So rho dot equal to P rho by m cosec square alpha. And P phi equal to del phi dot L. And this the phi dot is so half m rho square twice phi dot. So this half cancel. So m rho square phi dot is rho dot equal to P phi by n rho square, equation 5. Since the Lagrangian L does not contain the time t explicitly, the Hamiltonian H equal to T plus V is the total energy, and is given by H equal to P. Already we have the expression for T is this, and V is this. So Hamiltonian is this. So put the values of phi dot and rho dot from 4 and 5, and after simplification, we get the equation 6 for Hamiltonian. The Hamiltonian equations of motions are for rho and for phi. Rho dot equal to del p rho h and this is equal to h with respect to p rho. So this is the p rho. So this twice p rho and 2 to cancel. So this p rho by m cosec square alpha, and p rho dot equal to minus del del rho h. So with respect to rho is this rho square. So this rho p phi square by m rho cube, and this is the rho. So mg quad alpha minus mg quad alpha. This negative sign here. And for phi, is phi dot equal to del del p phi h, and this equal to p phi m rho square, and p phi dot equal to minus del del phi h. This is equals to 0. And note that we can also find h by this formula summation pk qk dot minus l, and the same expression for h. Next question, question 4b. So that the integral j1 equal to double integration over the surface S summation I dqi dpi taken over an arbitrary two-dimensional surface S of the 2n-dimensional stage space is invariant under canonical transformation. Let qk comma pk, that is here qk means q1 q2 up to qn, comma p1 p2 p3 dot dot up to pn be a set of twice n variables of generalized coordinates and their corresponding conjugate momenta respectively. This q k is the coordinates, generalized coordinates, and corresponding conjugate momenta, and pk. To characterize a given state of a physical system, then the corresponding phase space qp is 2n-dimensional space with qk and pk denoting twice n numbers axis system. And similarly, for this capital Qk and capital Pk, the another phase space with two n other variables, a new set of variables. This we have to prove the volume J1 equal to surface integration over S summation I dqi dpi taken over an arbitrary two-dimensional surface S of the 2n-dimensional phase space is invariant under canonical transformation, and this is known as Poincare's integral invariance. And then one actually implies that surface integration over S summation I dqi dpi is equal to surface integration S summation over I d capital Qi d capital Pi. The position of the point on any two-dimensional surface is specified completely by two parameters u and v, as qi equal to qi is the function of up, and pi equal to pi is the function of up, I equal to 1 to small n. In order to transform one this integration and volume integration and the surface integration this into variables uv, we have dqi dpi equal to this del qi pi del uv modulus of this into du dv, and this is the Jacobian j. Is from the calculus we observe this result, where j equal to this is the Jacobian of the transformation. And using 4 from the equation 2, we get this double integration over S summation over I del qi pi by del uv du dv. So this is the double integration over S summation over del qi pi del uv du dv. The surface is arbitrary, so from 5 we can write this summation over del qi pi del uv summation over I del capital Qi del capital Pi del uv equals 6. Provided capital Qi and capital Pi are derived from small qi and small pi and through a canonical transformation. Thus, the given Poincare integral uh, invariance problem, this actually would, which would itself imply the invariance of J1. So we have to prove this equals 6. We have to prove this the transformation small qp to capital QP. So the generating function F2 type. So F2 type is small q capital P comma T, and then we have this Pi equal to del Qy capital F2 and capital Qy equal to del capital Pi capital F2. So del u Pi equal to del u del Qy F2 because Pi equal to this. So summation over j and this equal to actually is del Qj and del Qy F2. So del Qy del Qj del u plus del capital Pj del F2 del Qy into del Pj del u. This is the derivative partial derivative with respect to u. So this del F2 del Qy is same fixed, and F2 is a function of q and p, small q and capital P. So del Qj del u, and del capital Pj by del u. Or this del u pi equal to summation. So we can write this del 2 f2 del qj del qy del qj del u plus summation over j del 2 f2 del capital pj del qy del pj del u. And similarly, del vpi equal to summation over j del 2 f2 del q j del qy del v qj plus summation over j del 2 f2 del capital pj del qy del v pj capital pj. Now, summation over this Jacobian del qypi by del qv, this equals to this, and del qi del u and del pi del u from this equation 7, we can write this term for del u pi. And this del vqi and del vpi is right can be write this from this equation. This we write this. And then we can write this summation over j and summation over I. This is equal to del 2 f2 del qj del qy, this term. So eh, this and this term. So this is the determinant of this del u qy del u qj del vqy del vqj, and this common is del 2 f2 del qj del q plus double summation over j and I, del 2 f2 del pj del qi is equal to del qi del u and del pi del u and del vqi and del vpj. Actually, this is the addition rule for determinants of this. And this first term on the right hand side, so this term is this is an antisymmetric expression under the interchange I and j. So if we expand this determinant this or this, so this is value is 0 del ui qi del vqi into this minus this into this. Actually, if we interchange this I and j, then this determinant is 0 del 2 qi qj u and v this interchange this. So this determinant 0. So actually, this reduces to this. The second part is this. Also, since we have this summation over j, summation over I, del 2 f2 del pj del capital pi pj in del pi, this equals to del u pi del u pj del v pi del v pj equals to 0. Because these terms of the antisymmetric expression under the interchange of the I and j, so its value is 0. So if we add this on by this term, so no effect this to right hand side of 8 without changing the value of left hand side. So left hand side is this summation over I del qi by del qv. So the equal to this plus this term, this plus this term. Next, we add these two determinants and this summation over j, summation over I, del 2 f2 del capital pj del qi, del qi, and this del 2 summation over this plus this, and this common del u pj del u pj. So this is the common, and this similarly this term plus this into this plus this into this this into this, and this term is same del del v pj del del v pj. So you can write this term equal to del del u capital Qj, del del u Pj is this term, and this term is del del v Qj, and this del del v Pj is equal to, because this del del u Qj equal to del del u del F2 del Pj, and this equals to summation over, because this Qi equal to del del Pi F2, del del capital Pi F2, del del capital Pi F2. So we write this Qg equal to del del capital J2. So similarly, we can write this del capital Pj F2 equal to this, and del del Qi into del del Qi del u, and del del capital Pi del del capital Pi del u. So we get this term. So this term equals to, this is the one position in the determinant is del del u capital Qj, and similarly del del v capital Qj for this 2 1 position element in the determinant. So from this 9, expression 9, we can write this summation over I del small qi small pi by del uv is equal to summation over j del capital Qj capital Pj by del uv, which implies that the integral j1 is invariant under canonical transformation. Next question 4c. 1. Using Hamilton's equation of motion, so that the Hamiltonian h equal to p square by twice m e to the power minus rt plus half m omega square x square e to the power rt leads to the equation of motion of a damped harmonic oscillator x double dot plus rx dot plus omega square x equals to 0. And number 2, if the Lagrangian of a two-dimensional harmonic oscillator is L equal to half m bracket r dot square plus r square 3 dot square bracket close minus half k r square, where k is a constant, then determine the Hamiltonian of the system. This is the Hamiltonian H is given in the problem. This, so Hamilton's equation of motion is given by this x dot equal to del del ph. Here, this x is the only generalized coordinates, and p is the corresponding momenta for x, and omega r m is the mass, and this r p is the time variable, r are all constant here. So x dot equal to del del ph, so with respect to p, so this twice p by twice m e to the power minus rt, so p by m e to the power minus rt, and p dot equal to minus del del x capital X. So this del del x, so we have this half m omega square twice x e to the power rt. Here p is the generalized momentum conjugate to the generalized coordinate x. Differentiating 2 with respect to t, so this m into x dot, so m into x double dot, and this p dot, dot means ddt, so p dot into e to the power minus rt plus e to the power p by m, and p by m is here, so p into e to the power minus rt into, in differentiating minus rt, so this is minus r, so this is the minus r. So we get using this p dot, value of p dot from 3, this minus m omega square x to the power rt, and this p to the power minus rt from 2 is p to the power minus rt equal to m into x dot. So putting the values from p and 2, we get this m is a non-zero quantity, so x double dot plus rx dot plus omega square x is the required equation of motion. Next part 2 question is L equal to this, determine the Hamiltonian of the system. So Lagrangian is this. Here r and theta are generalized coordinates, and pr and p theta are the generalized momenta conjugate to r and theta respectively. So from this pr equal to del del r dot L. So del del r dot l is equals to r dot is here. So half m twice r dot. So this m r dot equal to pr by m. And p theta equal to del l theta dot l. Theta dot is here. So half m to r square twice theta dot. So theta dot equal to p theta by m r square. The Hamiltonian age is given by this summation over j pj qj dot. Pj means the pr r dot plus p theta theta dot minus l. So this put the values of r dot and theta dot from 2 and 3. And L is this. Here also r dot equal to pr by m and theta dot equal to p theta by m r square. And after simplification, we get Hamiltonian in terms of this r theta, pr, p theta, and this. This is the required Hamiltonian of the system. Next question, 4D. A system is governed by the Hamiltonian H equal to this, where A, B are constants, Px, Py are momenta conjugate to x and y respectively. Find the values of A and B so that the quantities Px minus 3y plus Py plus twice x are conserved. Here Hamiltonian is given by H equal to half bracket Px square minus Ay square whole square plus half Py minus Bx whole square. Then del Px H equal to this 2 into Px minus Ay and del Py H equal to this Py minus Bx and del x H equal to with respect to x. So this half into 2 into Px minus Ay and this equals to minus b. So this from this term is independent of x here. So only from this term we get half into 2 into Py minus Bx into minus b for this system. And del y H equals to from this term, so half into 2 into Px minus Ay into minus a. The Hamilton's equations of motion are x dot equal to del Px H and this del Px with respect to Px, so this half into 2 Px minus Ay and E x dot equal to minus del x H. So del x H equal to this. Y dot equal to del Py H. So del Py is this Py minus Bx and Py dot equal to minus del Yh. So this and this using this we get 4, 3, 4, 5, 6. Now ddt of Px minus 3y equal to this Px dot minus 3y dot. So Px dot equal to by 4 this and y dot equal to Py minus Bx. So we only put the values of Px dot here. So Py dot equal to this and again putting the value of Py and this Py from 5 Py equal to y dot plus Bx. Cancel Bx minus Bx and b minus 3 common and this y dot. This equals to 0 because this px minus 3y is conserved. So this equals to 0 if b equal to 3. So answer is b equal to 3. And similarly, ddt of py plus 2x equal to this and putting the value of py dot from 6 and this again from 3 I put the value of px put the value of px from 3 and after simplification we get a plus 2 into x dot equal to 0 and so it conserved. So this a plus 2 equal to must be 0, so equal to minus 2. The note of this PDF is given in the description box. Thank you for watching this video.